Alrighty, so the first one says to state the excluded values. So whenever we do that, we just set the denominator equal thou shalt not divide by 0 in math, so it's not the whole problem. It's just the denominator. So for this one, x cannot equal 3. With every lesson that we've done, it's always been factor first. So when I get to number 3 right here, I'm going to make sure that I difference of squares that. And then you set those each equal to 0 or not equal to 0 since it's excluded value. And we get x cannot equal -5 or 5. And then for this one, again, the denominator cannot equal 0. So I'm going to go ahead and t-chart that so that I can factor first. And -8 and +2 crisscross add to the middle. So we get x cannot equal 8 or -2. All right, moving on to simplify. So you will have 2 of these on your test. So the first one is kind of tricky. It has a -1 in common. So anytime there's that negative in front, make sure you factor it out. And then I'm going to t-chart that bottom. Crisscross, add to the middle. And then these are common factors. So I'm left with -1 over x plus 5. What you want to notice though is that the problem does say that you need to also state the excluded values, and it's the same thing on your test. So make sure that you go back to the original and then your excluded values are x can't equal -3 or -5. Okay, number 6, we're going to have a GCF here. So we're going to look at what they have in common, which is a 2x. And then it's going to be x squared minus 36. Uh-oh. The bottom has the GCF too, but then I don't know if you see this right there. That's a difference of squares. So that x squared minus 36 can be factored more into x plus 6 over x minus 6. And now we just get to cancel common factors. Before I do that, it's sometimes easier to state your excluded values. So for this one, the excluded values are x can't equal 0 or -6. And then I'm going to cancel the x's because they are common factors. And I'm going to cancel the x plus 6's. So the denominator canceled. So this could be your answer, or if you want to write it in term form instead of factored form, which you don't have to because it doesn't change it, you could write it like that. Next one, we're just going to do a bunch of t-charting. You and me both. So the top is going to t-chart into x plus 5 over x plus 1. And then the bottom t-chart I think 10x and negative 1x makes crisscross to positive 9x. So that is 2x minus 1 times x plus 5. And then for excluded values here, if we set each of those denominators equal to 0, the first one is really easy to see, which is that negative 5. But the 2x minus 1, you have to add 1 and divide by 2. So it also has 1/2 in there. Now I can cancel common factors. And I get x plus 1 over 2x minus 1. And I wouldn't cancel these guys right here, even though you feel like you might want to, because they're connected by a plus and a minus, so they're not cancelable. Next one, we have negative 9x. And then down in the bottom, we have a 3x in common. So my excluded values are x can't equal 0 or 7. So remember that 3 in front there doesn't matter. It's a constant, so it can't ever change to 0. And then as far as canceling goes, negative 9 is negative 3 times 3, and then there's that x there. So if that's the case, then I can cancel one of those 3's with that 3 down there, and then one of those x's with that x right there, and that leaves me with negative 3 over x minus 7. You could put parentheses around the x minus 7 if you want, or not. Okay, for this one, we are going to do the same thing. It says find the product, but then just be aware, it also says state the excluded values. So when it says that, just make sure you know it's before you simplify. So what we're going to do here is GCF that. And then the x minus 2's are going to cancel, but just to make sure that you get your excluded values in there, x cannot equal 2, even though it got canceled, and negative 5. And then our answer for this one is just x over 7 times the quantity x plus 5. This is all you're going to keep doing, is looking for those factors that can cancel. So x minus 9, and I see this 3 up here. So what I'm going to do is actually write 12 as 4 times 3 so that I can cancel those. And then these have a 5x in common. And I'll put parentheses around that. And then these cancel, and this 3 and this 3 cancel. Everything in the numerator canceled, but there's still a 1 in there. And then you have 4 times x times 5 times x, which is 20x squared. Excluded values. X cannot equal 0 or 9. Still multiplying. It says find the product. That just means multiply. So just keep on T-charting, GCFing, all of that. This one has a 2x in common. this is a difference of perfect squares. And then the bottom one, we can t-chart. So we get x minus 3 times x plus 10. And then if we go to cancel stuff out, we have common factor, common factor, common factor, common factor. And then you might not see this, but x squared is x times x, in which case one of those x's is going to cancel with the x down below. So then you end up with, in the numerator, just an x, and in the denominator, you have an x plus 10. Oh wait, what else did I miss? That too. So for our excluded values, you have 0 from this guy, then you have negative 3 from that one, then you have positive 3 from that one, and negative 10 from that one. Okay, so first step whenever we're dividing is keep, change, flip. Keep the first fraction, change the second one, and flip, oh sorry, keep the first one, change the sign, flip the second one. And then we can go ahead and GCF or factor whatever we can. So then that x minus 5 and that x minus 5 cancel. So then we end up with 7 times x plus 8. So the 7 is coming from here, and here's the x plus 8. You have to put it in parentheses, all over x. Ooh, excluded values with dividing are a little tricky because in the beginning we had this 7x minus 35. And so if it's ever in the denominator, you have to exclude it. So we have 5, and then there's an x in the denominator, so then we have 0. This one looks intense, but just like a bunch of t-charting and GCFing. So we have x minus 2 all over. I'm going to just t-chart this one since I'm not going to flip it. And it's going to be x plus 9 and x minus 2. Change the sign. And then I have to flip this. So this one right here originally started in the denominator. So whenever we factor that, we're going to have to make sure we exclude it. Okay. When I factor that numerator by t-chart, I get x plus 9 times x minus 1. This one has a GCF. And then I'm going to have to t-chart the parentheses. Crisscross, add to the middle. And then from there, we're just going to cancel and then find our excluded values. So the x plus 9s cancel, the x minus 2s cancel. And then I just end up with x minus 1 all over x times x minus 9 times x plus 3. And x cannot equal, man, there's a bunch of them. So looking at that copy dot flip or that keep change flip, we need to include those ones right there. So that's what, -9 and 1. And then we also need to keep anything down here that we haven't already excluded. So we already did -9, but then there's a 2, a 0, a 9, and a -3. That's a lot. That's not a 12. Okay, so in order to add these, the denominators need to be the same. So this one needs an x, and this one needs a 3 plus x. And again, because that 3 minus x has two terms, I'm going to go ahead and put parentheses around it. So we do not do property of equality on this problem. Do you see an equal sign anywhere? No. So you just leave the denominator as is. So it's x times 3 plus x. And then in the numerator, we just copy what is written. And then we're going to rainbow that 3 plus x and the 3 minus x so that we can combine like terms. So with that, I get 9 minus 3x plus 3x minus x squared plus 11x. Again, when we combine like terms, we keep the common part of the like terms. In this case, it's the denominator. Then negative 3x and positive 3x cancel. And I have negative x squared plus 11x plus 9 all over that common denominator. And my excluded values are going to be x cannot equal 0 or negative 3 from the 3 plus x. Okay, moving on to 15. There's a minus sign. So every time I see that, that makes me pause for a second to make sure that I'm going to be doing what I need to do with that subtraction. So first thing I'm going to do is t-chart that bottom, and that ends up t-charting into x minus 6 times x plus 5. Are the denominators identical? No. Get them to be identical. So this one needs an x minus 6, and this one needs an x minus 6. So I have that common denominator. I have to keep it because there's no equal sign. Doesn't matter which order you put that in. And I have x minus 1 times x minus 6. And I just want to be really careful about rainbowing that. So I get x minus x plus 6 all over x plus 5 times x minus 6. X's cancel. And that gives me 6 over x plus 5 times x minus 6. Excluded values, we just have 2. X cannot equal negative 5 or positive 6. Now we're going to move on to 16. For 16, same thing. Step 1 is always to factor first. I'll try and remind you of that. Again, that minus makes me pay extra special attention. The denominators are not identical, so I'm going to get them to be identical. If it is getting multiplied and it has two terms, it needs parentheses. We now have that common denominator. And then this one, you just need to be careful because you're going to multiply using the rainbows, but all of it needs to be subtracted. So make sure you put big set of parentheses. So that's x squared minus 5x plus 4x minus 20. And then just to make my life easier, because I can combine like terms, negative 5x and positive 4x is negative x. So when I go to rainbow that negative in, I have 1 minus x squared, and then it's going to change that to positive x and positive 20. And then we have negative x squared plus x, and then these like terms right here of 20 and 1. And then excluded values, x can't equal negative 5 or 5. Okay, when you're solving them, same thing that we did, you have to get common denominators. So this one needs a 4, this one needs an x, and this one needs a 4. Now, because we have that equal sign, we can use the property of equality and say we don't need to look at the denominator anymore. It's already in common. So we're just going to look at 4 times 5, which is 20, plus 7x equals, watch out for that negative, negative 36. And then same old, minus 20. And then that gives us 7x equals negative 56. Divide by 7. And then x equals negative 8. The only excluded value was 0, so this is a good solution. For the next one, same thing. Get these to match. 2 of the 3 match. So this is the only, oh, they don't all the way match, sorry. This is an x minus 1. But both of these guys need a 2 to get them to match perfectly. Now that I have them all, those denominators equal, they have a 2 factor and an x minus 1 factor. I can focus on the numerator. And then rainbow method. Combine like terms on each side first, and then subtract 5, subtract 5, subtract 2, subtract 2, x. And I get x equals negative 3. And the excluded value is only x cannot equal 1. So this is a very good one. Okay, so now we're going to solve this last equation. And so the way we're going to do that is the same way we've done before. Get the denominators to match and use the property of equality. So this denominator can't be factored. Just going to put parentheses around it. This denominator is the difference of squares. And again, watching out for that minus because it's going to impact your answer, so be aware of it. So the goal is to make all the denominators identical. This middle one has an x plus 3 and an x minus 3, but this first one doesn't have that x plus 3. So now it's identical. And then this last one doesn't have the x minus 3. So I'm going to put the x minus 3 up there. And now they're all identical. So this is where we say, because the denominators are equal, the numerators must also be equal, which is the property of equality. So basically, we get to say that these are equal. That's my giant E. So we don't need to worry about them because now all we got to do is make the numerator equal. So I'm going to copy down my numerator, being very careful to make sure I copy it down as is. Then I have some distributive property, which we call rainbows sometimes. I get 6x plus 18 equals 8x squared minus 4x squared plus 12x. And then combine like terms on the sides individually first. So 6x and 18 can't be combined, but 8x squared minus 4x squared is 4x squared plus 12x. And then because the highest power of x in our problem is 2, we are going to get one side equal to 0. I like my x squared term to be positive, so I am going to be subtracting from the left side. So that leaves me with 0 equals 4x squared plus 6x minus 18. And then that has a GCF. So everything can be factored by 2. And then to solve that, I'm going to t-chart. So I have 2x squared, 3x, negative 9, 2x, and 3, negative 3 and x, crisscross, add to get that. So that means that I have 2 times 2x minus 3 times x plus 3 equals 0. I just switch the sides. And then from there, you set each piece equal to 0. 2 equals 0, not a true statement. Ignore it. 2x minus 3 equals 0. Add 3. And you get 2x equals 3. And then divide by 2. So x equals 3 halves. And then x plus 3 equals 0. Subtract 3. So then you get negative 3. But be careful, because if you look up here at your excluded values, you can see that x can't equal negative 3 or 3. So this is not a good solution. So the only solution is x equals 3 halves. We got 2 more problems. There are graphing problems. So let's take a look at those. So anytime you want to find out how to graph a rational expression, I always say look for the 3 zeros. So the first one is set the numerator equal to 0. So that's going to give us our x-intercept. So we get x equals 3, but in intercept form, that's 3, 0. So right there. Then you're going to set your denominator equal to 0, and that is not going to give you your y-intercept. That wouldn't make sense because you get x equals negative 1, and a y-intercept would be y equals. That's going to give you your vertical asymptote because the denominator is what the equation can't equal because it would be division by 0, and we can show that on a visual graph with a vertical asymptote. And then the third 0 is plugging in 0. And that will be our y-intercept. Because if you ever want to know your y-intercept, you plug in x equals 0, which gives me negative 3. So that's 0, negative 3, which is here. And then finally, what I'm going to do is I am going to look at this and get my horizontal asymptote. So the horizontal asymptote actually comes from the ratio in front of the numbers in front of x. So right here. So this would be y equals 1 over 1, which equals 1. So this is the horizontal asymptote. Make sure that when you write these, that you do put x's and y's in front of them. So now I know that I have this right here as part of my graph, but these graphs have two parts, so I need to know what it's doing to the blink side of the asymptote, which is this side, because I know what it's doing over on this side. So I'm going to always pick, for my preference, my test point is always going to be the number to the left or just one away from the asymptote. So that's going to be -2, and then I plug that in. Which equals -5, so my test point is going to be -2, -5. JK, it's going to be +5 because a negative divided by a negative is a positive. And since it's in the upper part, it's going to coast along there. So there is a lot of steps when you're doing that, but you can make it easier on yourself just by remembering the rule of zeros. So again, numerator equals 0. That's going to be that x is -4. So that's my x-intercept. Then the next thing is that the y equals 0, which gives me x equals 4, and that's going to be my vertical asymptote because it's the excluded value. Then I'm going to do my y-intercept, which is plugging in 0. So numerator 0, denominator equals 0, then you plug in 0. So that gives me 4 divided by -4, which is -1. So that's here. And then to find my my horizontal asymptote, I'm looking right here. And there's a 1 there and a 1 there. So it always starts with y equals, and then it's 1 over 1. And then I can see right here that it's coasting along the left. And so this side of the asymptote is taken care of, but I still need to figure out this side. So I need to pick a value in this side. So I'm going to pick one number after the asymptote. And since the asymptote's at 4, I'm going to pick my test point to be x equals 5. And then I plug that into the equation. And I get 9 over 1. So that means 5 and then 9, which is here. So it likes to coast along the upper part of that. And that is our review worksheet.